You do not always need to train a re-ranker to improve BM25. Cohere Rerank lets you upgrade candidate results with an API-first workflow. You'll learn the shape of a workflow that re-ranks BM25 hits with Cohere scoring. I'm Professor Pi, teaching search and IR with simple Python. Search teams often start with BM25 because it's fast and predictable. BM25 pulls documents that share words with your query, and that's enough for many cases. But lexical signals miss paraphrases and intent. A re-ranker fixes that. Keep BM25 for recall and speed. Then send a small shortlist to a semantic model to reorder results based on meaning. The high-level move is straightforward. Use BM25 to pull candidates. Use Cohere Rerank to score and reorder them with deeper language understanding. You keep low-cost lexical filtering and add a targeted semantic lift. The typical payoff is better top results after only a few extra API calls. We'll build a tiny pipeline that benchmarks BM25 on a small VPN troubleshooting corpus, packages the top 3 hits, calls Cohere to re-rank them, and measures rank lift. This makes the practical trade-offs clear before you scale the pattern to larger indexes. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we run a quick BM25 baseline on the VPN corpus to see where lexical ranking lands. This snippet quickly benchmarks how far pure BM25 scoring gets you on the VPN docs. We tokenize the document strings and feed them into BM25 Okapi. Then run get scores with the same lexical query so you can plainly see which documents match by shared terms. By taking the max over the enumerated scores, we pull out the strongest candidate index, and the raw score will later compare against the re-ranker. The printed baseline doc shows BM25's current winner and the BM25 score you'll use to judge improvement. Now that we know what BM25 returns, we need to shape those hits into a tidy candidate set for a re-ranker. This example organizes the BM25 baseline into structured candidates for later re-ranking. We sort indexes into baseline order, then build top candidates so each entry keeps doc ID, text, and score together. That makes it trivial to align lexical and semantic signals later. Averaging those scores gives you a quick sense of how strong the candidate pool is before sending it out. The printed baseline rank order confirms which documents you'll forward and what their mean score looks like going into Cohere. With candidates packed, the next step is to actually call Cohere and ask it to re-rank the shortlist. This code wires the Cohere client so we can actually re-rank the lexical shortlist. We authenticate with client v2 using the Cohere API key and call co-rerank with the same query plus our documents list. Using model rerank v4.0 fast keeps latency reasonable for tests, while top n equals 3 mirrors the candidate pool we curated. We hold re-rank results so you can inspect both returned indexes and semantic scores. The printed Cohere top doc index shows which document Cohere prefers now, and the Cohere score indicates its confidence. Once we have semantic scores, we must compare ordering to see if anything moved and by how much. This snippet checks how far the re-ranker moved your winner. We build re-rank order from Cohere's output and compare it to baseline order to see differences. Calculating baseline pause and rank lift tells you how many spots a document was promoted without juggling raw scores. So you can log or alarm when the semantic model overrides lexical ranking. These compact metrics give engineers a quick sanity check before rolling the re-ranker wider. The printed promoted doc index and rank lift show which document jumped and by how many positions. Finally, wrap the pieces into a reusable function so you can call hybrid search from other services. This example wraps everything into a callable helper so hybrid search is easy to reuse. Re-ranked search recomputes BM25 scores, grabs the top 3 indexes with heap q.n largest, and hands their text to Cohere while avoiding stale candidates. Result captures the API response inline so the pipeline stays tight, but still lets you tweak model or top N for quality versus latency experiments. By returning both the original index and Cohere relevance score, higher-level code can log deltas or merge metadata without extra lookups. The printed final doc index and final Cohere score confirm which item you'll ship to users after re-ranking. In a real system, the same flow maps naturally. BM25 lives in an inverted index for fast recall. The re-ranker runs only on a tiny critical path, called for the top candidates. Add logging for rank lift, and watch for cases where the re-ranker consistently disagrees with BM25. Quick recap. Use BM25 for wide recall, then run Cohere Rerank to improve the very top results. Reach for this when lexical search usually gets you near the answer, but misses paraphrases or intent. One caveat: you trade a few API calls for that quality lift, so monitor latency and error budgets. Next step, tune BM25 K1 and B to change how aggressive lexical recall is. Then remeasure how often the re-ranker makes meaningful changes. If short practical IR helps you, subscribe and watch the IR videos.